Okay, so we're talking about doing division, and what I want you to notice is both of these expressions have exponents that are rational numbers. And the easiest way, the quickest way, is to just go ahead and do the division. What throws you guys off is you see these fractions and you think I'm asking you to divide fractions. I'm not. This does not say 8/3 divided by 5/3 because these are exponents and they're connected to variables. And I'm asking you to divide variables, and to divide variables, what do you do with exponents? You subtract them. So the quickest way to calculate the answer here is just to go ahead and keep everything as rational exponents. So I'm going to divide my coefficients first. So 20 divided by -4 is -5. Everybody agree? X to the 8/3 divided by x to the 5/3. I'm dividing variables, x's. So I'm going to subtract my exponents. Well, how do you subtract fractions? You need a common denominator. I have a common denominator, 3, so I can just go ahead and subtract. 8/3 minus 5/3 would be 3/3. So this would be x to the 3/3. Now, can I leave my expression like that? Absolutely not. 3/3 is a fraction. It can be reduced to be the value 1. Is my answer -5x to the first? Absolutely not. We never write in algebra an exponent of 1. So this would just be, our quotient would be -5x. Now, that is the quickest way to work that expression, but it's not the only way. Why this is in our module about roots is you need to remember, anytime you have a rational exponent, you could have rewritten this expression as a root. So just to show you how I can work it another way that's correct, I have a 20. And this is a root. The denominator is the root, so this is the cube root of x, and the numerator is still the exponent, 8. In the denominator, I have my coefficient, -4. I have a fraction as an exponent, which means a rational exponent can be changed into a root. The denominator is 3, so it's still the cube root. The variable is x, and now the exponent on it's 5. And now we're back to the previous module. We would divide 20 divided by -4 is still -5. We could divide because our index are the same. We're dividing by cube roots. And so this answer would be in a cube root. X to the 8th divided by x to the 5th. We would subtract our exponents and get x cubed. But we couldn't leave this as the answer because we'd actually have to do the cube root operation. What is the cube root of x cubed? Well, we all know that. What term do you multiply 3 times to give us x cubed? And that would just be good old x. And we would get the same quotient. Now you tell me which way was quicker. Keeping it in terms of rational exponents and then just subtracting the fractions, or rewriting it in root radical form and then doing the division. It doesn't matter to me which approach you go with. Just pick the one that you feel more comfortable with. Okay, look at our next expression. Y to the 1/3 divided by y to the 1/6. So we're dividing y's, and the rule is when you divide variables, you subtract your exponents. So your exponents here are 1/3 and 1/6. But can you subtract those exponents? No, because to subtract fractions, what do you all need? That's right, a common denominator. What's the common denominator of 3 and 6? Very good, it's 6. So each of these denominators have to be a 6. How does 3 become a 6? We multiply by 2, so when we multiply the numerator by 2, we get 2. So now this expression is y to the 2/6. The denominator's expression is okay because it's already in terms of 6. It's y to the 1/6. So now that we have a common denominator, we can subtract. Y to the 2/6 divided by y to the 1/6 would be y. 2/6 minus 1/6 would be 1/6. So that quotient would be y to the 1/6. That is written in with a rational exponent. If they asked you to write this answer in radical form, that would mean to write it as a root. And we can change. Anytime you have an exponent that's a fraction, you could change it into a root. The denominator is the root, so this would be the 6th root of the variable y, and the exponent on it would be 1, which is understood. If we write it in radical form, we have to make sure we can't reduce it. And you can't. Sixth root means you need 6 of the same term. You only have one y inside, so that is in simplest form. Now, what I want you to note is if you wrote this as roots first, you wouldn't be able to do division. Because if you wrote y to the 1/3, that term as a root, it would be the cube root of y. And if you wrote y to the 1/6 in root form, it would be the 6th root of y. And these indices are not the same, therefore you couldn't proceed with the division, because that's all you know how to do. You only know how to divide if the roots, the index, are the same. So the moral of the story is, don't be afraid of rational exponents. It's easier to work the expression with the fraction as the exponent by subtracting the exponents first and then changing it into radical form. Okay, more division to come. See you soon.